This is Unit 2, Lesson 9, Solving Inequalities. We have 3 objectives. The first objective is to understand which rules of expressions that we've learned do or don't apply to inequalities. Second thing is to understand how to solve inequalities. And the third objective is to understand how to represent inequalities on number lines. Let's take a look at Objective 1. Which rules apply and which rules don't apply? Well, remember the additive property of equality? Let's think about that for inequalities. If I have an example, say 4 is greater than 3, which I know is true. What if I were to add 1 to both sides? Is it true that 5 is greater than 4? Absolutely. So if I start off with a true statement and I add something to either side, I still end up with a true statement. This works for subtracting, which is still adding, correct? In other words, if 4 is greater than 3, if I add negative 1 to both sides, which is usually we just say subtracting 1, but is it true that 3 is greater than 2? Absolutely. So if I start with a true statement and add something to both sides, I end up with a true statement. What about another property of equality? What about multiplying, the multiplicative property? Let's try that. What if I have, again, 4 is greater than 3, but now instead of adding, what if I multiply both sides by 2? So I know that it's true that 4 is greater than 3. 4 times 2 is 8. 3 times 2 is 6. Is it still true that 8 is greater than 6? Absolutely, it's true. So it would seem at first that multiplying both sides by a number will keep the statement true. However, watch this. What if now I start with 4 is greater than 3, but now I multiply both sides by negative 2? I have negative 8 and negative 6. Let me keep this the same here. I start off with a true statement. Is it still true that negative 8 is greater than negative 6? No, negative 8 is smaller than negative 6. So what we've learned here is that multiplying, the multiplicative property of equality does not translate to inequalities, even though an additive property of equality does translate. In other words, it works for both. Well, it doesn't mean we can't do this. What it means is we just have to be careful. What do you notice here? Even though this is not true, if we were to simply change the direction of the arrowhead, it now becomes true. In other words, negative 8 is less than negative 6. Well, this is going to show us what we want to do when we're confronted with these types of problems. If we multiply both sides by a negative number, to keep the statement true, what we have to do is we have to switch the direction of the arrowhead. If it's to the right, switch it to the left. If it turns out that it started on the left, switch it to the right. One more quick example. If I have 4 is greater than 3, just to remind you that dividing is really the same thing as multiplying. What if I'm divided by negative 2, which is the same thing as multiplying by negative 1/2, right? The same little rule that we've just learned is going to apply. Negative 1/2 times 4, or 4 divided by negative 2, is negative 2. 3 times negative 1/2 is negative 3/2, or negative 1/2, correct? Well, we know that negative 2 is less than negative 1/2, and that's what we want to do anyway, right? What's the rule we just learned? If we have a negative that we're multiplying, then we need to switch the direction of the arrowhead, and that's all we have to do. Let's now move to Objective 2. solving inequalities. It's really nothing new. We're just going to apply what we knew from before this lesson to what we've just learned in this lesson. If I have an equation, 2x plus 1 is greater than or equal to 7, and I want to solve for x, I'm going to do it the same way that I did previously in previous lessons. Additive property of equality is also going to work for inequalities. So I'm either going to say I'm adding -1 or subtracting 1 from both sides. 2x is greater than or equal to 6, so I don't have to worry about anything with the inequality sign. Now I'm going to divide both sides by 2, and I'm left with x is greater than or equal to 3. Since I multiplied by 1/2, which is the same thing as dividing by 2, and it's a positive number, I don't have to worry about changing the inequality sign. So to make this statement true, all I need to make sure is that whatever I plug in for x is 3 or greater, and that will always make that statement true. Continuing on, what if I have this statement? -4x minus 1 is less than 11. Let's solve this for x. I'm going to add 1 to both sides, and I have -4x is less than 11 plus 1 is 12. Here's where our new little rule needs to be applied. I'm going to divide both sides by -4 or multiply both sides by -1/4. It's the same thing. Okay, so there's multiplying both sides by -1/4. And so what I'm going to do here is I'm left with -4 over -4 is +1. So the left-hand side is just x. The right-hand side is -3. So what I have to do now is switch the direction of the arrowhead. So the arrowhead is going to be from pointing to the left to pointing to the right. So to make this statement true, the value I pick for x has to be greater than -3. So -2, -1, 0, 1, 2, 3, any of those will make that original statement true. Objective 3, how do we represent these on number lines, these inequalities? I'm going to do 3 quick examples. What if I have x is greater than 2 and I want to represent that on a number line? I'm simply going to go to my number line, 0, 1, 2, 3, -1, -2, -3. And here's what I'm going to do. I'm going to put an open circle on 2, and then I'm going to put a line with an arrowhead pointing to the greater numbers. That's how I represent x is greater than 2. Another example. What if I want to represent x is greater than or equal to 2? I'm going to go to my number line, 0, 1, 2, 3, -1, -2, -3. Now what I'm going to do is to represent greater than or equal, I'm going to put a circle, but I'm going to fill it in. And then I'm going to have an arrow pointing to the bigger numbers. That's how I represent greater than or equal to 2. One last example. What about x is less than -1? Draw a quick little number line, 0, 1, 2, 3, -1, -2, -3. Since it's just a less than, I'm going to put an open circle. So at -1, I'm going to put an open circle. And less than -1 means to go to the left, because remember, to the right on a number line are bigger numbers. So now I'm going to have an arrowhead pointing to the left. So there's our 3 objectives for this unit.